Okay, in this video we're going to do a handful of financial problems here. These are the extra problems I made available before the test. So our first problem is on a loan of $25,000. Well, with a loan, uh, the present value is the amount that you borrow. So that's going to be 25,000. And our interest rate is going to be 8% a year. And it's going to be 4 years. And it says monthly payments, so we're going to have 12 periods per year. Okay, and if you look down here in these two white cells, I've got formulas down there that take the annual rate divided by the periods per year to get the rate per month or rate per period. And down here I've got a formula that multiplies these two numbers together to get the total number of periods. And these two numbers are the ones that have to be used, not the three numbers up here. Okay, we're trying to figure out the payment, so I grade that out, and the ending balance on a loan is usually zero, and we're doing end of month payments, so we need a zero down here. Okay, now we're trying to find the payment, so that's going to be the PMT function. So let's, with the cursor in this cell, let's go to our formulas and go to financial and scroll down to the P's and pick PMT. The rate is always the rate per period. Number of periods is always this number here, not necessarily the number of years. Usually not the number of years, because usually we're doing 12 periods per year. Present value in a loan is always the amount that you are borrowing. The future value is almost always zero. And then the type is going to be this 0 or 1 down here. Click on OK. And payment's always a negative number, so that's why it's red. That's why it's in parentheses. And so your payment would be $610 for 48 months to pay this amount of money back. Okay, problem number two. You know that you can afford to make monthly house payments. Whoops, I scrolled a little too far. Of $750. How much can you afford to borrow if for 30 years at 7%? So the annual rate is 7. 30 years, and it says monthly payments, so we're doing 12 periods per year. Starting balance is what we're trying to find out, and that's the present value, so that means we're going to be using the PV function. Our payment is $750, and our ending balance on a loan is 0, and we are paying at the end of the month, and 0 means end. So we want to do the PV function. So we'll go over here to our answer box, and we will scroll down to the P's and choose PV. And okay, that was kind of odd. I lost part of my function arguments box here for some reason. So the rate is always the rate per period. The number of periods is always this number here, years times periods per year. The payment is always negative. We got to put a minus sign in front of this, and then the 750. And the future value on a loan is almost always 0. And the type is the 0 or 1 down here. Click on OK. So if you're paying 7% interest and you can make $750 payments every month, that's how much you can afford to borrow, and you'll be able to pay it back over 30 years at this rate, making these monthly payments. Okay. Now let's take a look at number 3. How much money will you have 10 years from now? So the number of years is going to be 10. If you invest $2,500 at the beginning of each year, so our payment is going to be $2,500, and the interest rate is 12% a year, and compounding annually and only putting money in once a year. So the periods per year this time is 1. That's usually 12, but in this case it's 1, so you got to read the question carefully. The starting balance is we start with 0, so we need to put a 0 in there. And we are making our payments at the beginning of each year, so put a 1 in there. And now I want to find out what my ending balance is going to be. That's the future value function. So let's go up here and choose FV. And our rate is the rate per period. The number of periods is 10. The payment is always negative. Put a minus sign in front of it, and then click on the 2,500. The present value in a savings problem is always negative, although in this case, because it's 0, it doesn't matter. But if I wanted to replace this with another number later on, I would need the minus sign. So I'm going to put it in now anyway, even though it doesn't really make a whole lot of sense on this particular example. And the type is going to be the 1 or the 0 down here. Click on OK. And if we invest $2,500 a year for 10 years, and that's the interest rate, that's how much we'll have at the end of 10 years. How much money will you have in 15 years? So let's go here and do 15. And we start out with, so that's going to be present value, 100,000. And we're going to add 200, that's going to be our payment. At the beginning of every month, so we need a 1 down there, and the annual interest rate is 10%. And it says we're doing monthly compounding, so it's going to be 12 periods per year, and that's how often we're putting the $200 in. We're trying to find out how much we'll have at the end. That's a future value problem, so let's click in our answer box here, and let's go to financial and look for future value. My rate is here. My number of periods is here. My payment is negative, and 200, and my present value, this is a savings problem again, so that's a bunch of payments that I've already made, so I need a minus sign in front of that. And then the type is going to be this number down here. Click on OK. And if we start with 100,000, put 200 in a month for 15 years at 10%, we will have over $500,000 when we're done. Okay, number 5 and 6 look pretty similar here, and they are. You know that you will need $100,000 to pay for a child's college education in 15 years. So years is 15. The interest rate is 8%. We're doing monthly compounding. We're starting off with 0. We're trying to figure out what our payment's going to be. Our ending balance needs to be 100,000. And we are doing these at the beginning of the month, so we need to put a 1 down there. So I'm trying to find out what my payment's going to be. How much do I need to save? So let's do the PMT function. And the rate is going to be this. The number of periods is going to be this. The present value on a savings problem is a negative number because it's the sum of a bunch of payments. The future value is my goal. That's a positive number. And the type is going to be this down here, and click on OK. And it tells me I'll have to save $287 a month to reach that goal. Now, the next problem down here, I left all the numbers the same except for one thing. I said you start off with 20,000. How much do you need to save? So I'm going to have the exact same numbers down here. So I'm going to do a Control C here, and I'm going to paste them in down here. And the one thing I'm going to change is I'm going to change this to 20,000. Okay. Now it's the same formula. It's only that we've changed the number here, but we reference that number up here when it was 0. So if I copy this formula down here, it's going to change this to a 58, a 59, a 55, a 57, and a 60, which is exactly what I want if I move down 10 rows. I don't even have to do this problem a second time. I'm just going to right click on this and do a copy. I'm going to go down here and right click and do a just a regular paste. And if I start off with 20,000, it reduces the amount I have to save every month by almost $200. Looks like $190 left. But I didn't have to redo the problem because it was the same function, and the arguments relative to the formula here were in the same relative locations. So I could just do a copy and paste. And one thing you may have noticed on every one of these functions here is that I am always grabbing my arguments from these bottom 6 rows here that are in bold. I never use the top 3 up here. If I double click on this, bottom 6. Now one of them's not going to be used because that's the one that we're trying to find, but let's double click on this. Again, I'm not using the top 3. Double click on this, not using the top 3. Double click on this, not using the top 3. Double click on this, not using the top 3. So I am always using